I am Borneo Bill Gregory, Master's Certified Flight Instructor, Aerobatic at Aviation Performance Solutions in Mesa, Arizona. Today I'm going to talk to you about my article on merits of universal upset prevention and recovery training. Aircraft come in a wide variety of shapes and sizes, quite a bit of aircraft diversity. Each of them possess their own flight characteristics, and often they were going to require some sort of specific training to qualify to fly. Sometimes it'll be type ratings, perhaps a tail wheel checkout, but there'll be specific training involved. Upset training is something that not all airframes are going to be candidates. They're not going to be compatible with that type of training. Load factors, bank angles, things like that. It would be actually unsafe, possibly even illegal for certain airframes to try and conduct this sort of training. In view of that, it would be very advantageous to have the capability to provide training in one aircraft. Why is that? Well, for one thing, upset prevention recovery training is something that is a concern for everyone, all aviators. Doesn't matter the type of airframe, who you are as a pilot, how experienced, all airframes and all pilots are at risk. There are no exceptions to this. No one gets a free pass. So it would be really optimum if we could provide a one-course-fits-all training solution, because then you would be able to take people from various backgrounds and train them all simultaneously. ICAO, the International Civil Aviation Organization, they had called for an integration of several educational mediums, those being academics, on-aircraft training, and in a flight simulator. This has introduced the essential human factors learning elements. The value of transferable training, well, it is currently in use, isn't it? You can make a direct parallel with instrument training. The foundation is built on small, slow, simple aircraft that most people start training on, and slowly but surely they adapt to a larger, faster, more complex aircraft with very sophisticated avionics. This progression is the standard throughout the world, both in civil and military flying. There are very common laws and fundamentals that are equivalent throughout the flying regime. Aerodynamics, physics, the use of the primary flight controls, physiology, psychology. There may be some variation between airframes, but the fundamentals all hold true. And of course, an example of this is angle of attack. Angle of attack is the angle between the reference chord line and the relative wind. As you increase the angle of attack, the coefficient of lift increases to a point, at which point it starts to tail off. The diminishing coefficient of lift is due to separated airflow. Above the critical angle of attack, the coefficient of lift will actually fall off. And this is true for all aircraft. However, the response, what the aircraft does as you reach this critical angle of attack, it varies from aircraft to aircraft. It may be a G brake, as in many basic aircraft like a Cessna. It may be a high angle of attack descent, or it may be yaw divergence. You may block the vertical tail, and the aircraft may depart controlled flight in yaw. The wing stall is the aircraft's flight condition, which is largely associated with upset events. In fact, most often this event is associated with loss of control in flight, LOC-I. And this is the leading cause of aviation fatalities. The aircraft, again, has very different responses depending on its design to the actual stall. In the classic G brake, the nose is going to pitch down. In a sustained full aft stick with a high sink rate, you may have the nose above the horizon, and yet your flight path is with a significant descent. Departure from controlled flight due to yaw divergence, blocking the vertical tail. I think most importantly is to realize that when an aircraft is in a stall, when it's in an upset, the aircraft is no longer following the commands of either the pilot or the autopilot. In uncoordinated stalls, that would be slips and skids, you would most likely also have an uncommanded roll. This uncommanded roll is largely due to negative roll damping, and the aircraft will roll away from the ball. Of course, the whole desire at this point is to effect a recovery. The pilot's required response is going to be to push, to decrease the angle of attack below the critical angle of attack. This is going to be very essential to return you to controlled flight. In fact, this is going to be a universal first step. You need to ensure that you're not holding inappropriate rudder during this push step. This would only serve to complicate the recovery. So you wouldn't want to be chasing the ball. You just simply want to make sure that your rudder pedals are approximately even. Once the stall is broken, you will want to resume a normal flight profile. So you'll want to roll to wings level, which is essential to rotate the lift vector back into the vertical. This, of course, is going to orient your G-force, your lift from the wing, to provide a maximum benefit. Of course, your reaction would be opposite if you were in a nose high upset and you needed to lower the nose to regain airspeed. In that case, you would want to orient your lift vector out of the vertical. And then, of course, finally, you would like to establish your power and attitude. You want to return the aircraft to a desired flight control profile. Now, to do this training for various pilots from various airframes, we need the correct airframe. We want to balance realism versus safety considerations. The handling quality of the aircraft you'd want to maximize, but we need to offset that with a margin of safety. A representative aircraft that doesn't permit G loading, if it has low plus and minus G limits, that would completely constrain your training. We must provide a buffer for the students who will encounter errors during the recovery training. And of course, the preservation of the aircrew themselves and the aircraft is a huge priority over realism. Now, comparing an actual aircraft to a flight simulator. Because of the nature of the unusual attitudes, it is certainly paramount. It's imperative for the pilot to actually experience the sensations of the event. You've got changing flight attitudes and also associated G loadings. It will be hugely important to provide a realistic response at higher angle of attack and the side slip angles. One last but very important thing. In the aircraft, you have skin in the game. You are actually physically at risk, which of course is not true in the simulator. Now, there are drawbacks to Universal UPRT. Largely and most obvious, it is not your airframe. The cockpit and the controls will not be the same. The instrumentation, how the cockpit is set up, and the view out of the window may be markedly different. And of course, flying with a yoke versus a stick, left hand versus right hand, the control response of the aircraft, control harmony, these will all be different in the customer's normal or parent aircraft versus a universal training aircraft. Engine response can be quite different, and of course, a propeller-driven aircraft versus a jet aircraft will provide some changes. The aircraft handling will not match up perfectly. The pitch response and the roll rates will probably not be exactly the same in the training aircraft as they would be in the normal parent aircraft that the aircrew fly. Certainly, high angle of attack and side slip effects may be different as well. Now, a method where we can bridge between the training in the training aircraft with the flight characteristics of the actual aircraft, the answer to this would be a simulator. The cockpit and the controls in the simulator, even if it's not the exact same aircraft, are going to be far more representative and will look much more and respond much more similarly as the parent aircraft. You'll be able to attain airspeeds and altitudes that usually would not be readily encountered in the training aircraft. So the similar would provide you with a chance to experience high altitude, slow speed flight, and wing sweep effects. So a carryover of the UPRT training will be the fact that the response that the student should have learned will already be ingrained. The visual response will link despite the lack of physiological cues that are evident in the simulator. It is a cost-effective means of reinforcing the training that was experienced in the training aircraft. Now, if your flight organization has very deep pockets, certainly you can invest in an available high-performance flight in an aircraft designed for high-performance training at high speed and high altitude. The simulator, of course, is an option also for those people who don't fit in the aircraft. Some people will be too tall, some people will be too heavy. It's certainly not optimum, but it is better than no training whatsoever. This is a summary. The advantages of having a universal aircraft, one aircraft which we could train pilots from varying backgrounds, would provide a great deal of benefit. It would make it much easier to train a group of people from varying backgrounds. Now, although that training aircraft won't perfectly mimic their normal aircraft, it will allow them to learn the most important fundamental ideas on aircraft recovery. And while doing so, they'll have an opportunity to actually feel the G loading and bank angles, attitude changes that are going to go on during an actual upset. The differences between the cockpits and the aircraft performance, these changes, these differences, they can be minimized, abated, by including the use of a flight simulator. The flight simulator will provide them with an environment that looks very representative and a flight response in the normal flight regime. The simulators normally are not that representative at high angles of attack and high side slip angles. But this tool will be used to bridge, to take the on-aircraft training and make it seem realistic in a setting and situation that these pilots are normally used to. Aviation Performance Solutions specializes in the delivery of upset prevention and recovery training for pilots of all skill levels to dramatically reduce the loss of control in flight threat. We offer online, on-aircraft, advanced simulator, train the trainer, and integrated upset training solutions. Please visit us at our website at apstraining.com. Thank you for your time today.